So this is Hamid Tabrizi from Lamar University. I run this model in the Google Cloud, and you can see here I imported the data from the Google Drive. The data is uploaded to the Google Drive and then loaded in the code with the command drive mount. And here I call the libraries required to the run the codes, for example, pandas as a PD, numpy as an MP, and so on. And I read the file into the data frame called df using pandas PD using here as a pandas, and here I extract values of elevation from the initial data, and here I reshape the extract data into the shape location of -1 and 1. And here I split the data into the two sections in lengths of 80 and 20% for training and testing purposes. And you can see here that um, I did the same with regard to the time sequence. And here now I uh, reprinted the length of the extract sets of value, and you can see here that um, since the data that we are trying to use is consisted of separated points in times but needs to be unified as a singular line, we use the time series generator code to do so. And yeah, you can see here. And here is sequential LSTM and dense. And for example, for the sequential model is a linear stack of layers that are used to create a deep neural network. It is the simplest way to create a neural networks in cross. With a sequential model, you can create the neural network by adding one layer at a time, and each layer is added on top of the previous layer. And LSTM. And LSTM, long short term memory, is a type of recurrent neural network RNN that is used for processing sequential data. LSTM networks are designed to overcome the vanishing gradient problem that occurs in traditional RNNs. And the last one in dense. And dense layer regular um, is the regular deeply connected neural network layer. It is most commonly used and is the core building block of neural networks. A dense layer uh, performs a linear operation on the input data followed by an activation function. Here you can see. Yeah. So we use approach 25, and this model fit generated will train the program into predicting the series with the data available in test generator. And Prediction is then made based on the training data for the test data, and and all the corresponding data will then be reshaped into the usable format for Go plotting library. And here you can see three three traces traces that three traces are then introduced to trace the training data, testing data, and predicting data. You can see it, for example, in traced one, it has X of date train and Y is elevation train, and mode is lines and name is date. And you can see that for traced two, it has X of date test, Y is a prediction, mode is lines, name is prediction, and so on. And this is a layout. And you can see here that yeah, these traces will then be plotted as follows. For example, I'm gonna zoom it. Okay, please wait. Um, Here, for example, here. Okay, as you see that green line is ground truth, and the red line is the prediction. And you can see that, for example, here for example is 668, and here is 668. It's approximately close. And I think that if I use a poach, for example, 50, I don't know exactly, but if I use 50, the prediction and the ground truth will be gonna so closer, and the prediction is will be more accurate. Um, but I don't know exactly about this. And this is my Go graph of this code for J17, and I uploaded in a GitHub other command and other uh, file here in GitHub, and this is my Go graph. Thank you so much.